All right, everyone, welcome back. Today we're going to take a look at a slightly different topic, and that is going to be printing generative art, and specifically understanding the relationship between resolution, DPI, and PPI, which are terms that you'll probably see thrown around if you're doing this long enough. And so the goal here is to understand how these terms all relate and how they relate to prints, and also displaying art on digital screens of various sizes and dimensions. So I have a little component here, and this is going to do most of the heavy lifting for us. So I'm going to be focusing on talking about first kind of what these terms mean, and then we'll jump into TouchDesigner. We'll do a little quick work with some of these conversions, and then we'll do a little recap at the end. So first things first, what is DPI and PPI? So basically, these are measurements for different things and relationships to different things. So we have a physical piece of paper, which has dimensions in either inches or centimeters, depending on where you live in the world. This is very obvious. It's something that we've been familiar with since we were all kids. And yeah, not much more to say about that. I think everybody here is also very familiar with digital files, which are defined in terms of their resolution, and that's the number of pixels in their width and their height. Now, a further element here that I didn't mention in the chart is the actual rendering resolution. So you have a render calculation resolution, then you have the digital image file, which could be, again, an image or an MP4. And then we have something with a resolution. And the question is, when you take an image file, let's say a high resolution 4K image, and you want to print it out, what's the biggest size that you can print that image out at and have it still look nice and sharp and like a 4K image? And the answer to that question lies in the concept of dots per inch. So the difference between dots per inch and pixels per inch is simply the method of translation from an image file to a physical display medium. So an image file can be any size. And we know this intuitively because if you have a file that's, say, 2160 by 3840, you can have that file be shown at any size. So actually, if I go back to here I have an image called Swept that I have created earlier this year. This is 2160 by 3840 pixels. But just as I'm zooming, we can see that there's different sizes possible for this image to be rendered at. And so regardless of the file size, the actual rendering size is something different. And so that is what brings us to pixels per inch, which is how many pixels, literally, are displayed per inch of real screen. So if we have a 4K screen and a 4K image, that means that our pixels per inch is about as high as it can possibly be. But if you have that 4K image, well, actually, sorry, that was a misspoke, because having a 4K image on a 4K screen maximizes the information that you can convey on that screen, but the resolution of the screen actually doesn't tell us how many pixels there are per inch. We need to know the size of the screen. So a 4K image rendered on a 4K screen that is the size of, let's say, the laptop or desktop monitor that I'm looking at right now. That's 23.5 inches by 13.25 inches. Or I guess really that would be a little bit wrong aspect ratio. So there we go, 13.25 by 23.5. And so this gives us some insight into what our pixels per inch would then be. So let's take 2160 pixels and divide it by 13.25 inches, and we can see that we have about 160 pixels per inch here. Now, what if, for example, this was not a desktop monitor screen? What if it was a 55-inch TV? A 65-inch TV that I happen to know is about 55 inches on the tall side, or about 35 inches on the short side. So now we have the same exact image at now 61 pixels per inch because the actual screen itself is so much larger. So the point here is that we are unable to use only the image, the digital image file resolution in pixels. That is insufficient information to convert to the pixels per inch of a display. Even if we know that display's resolution, we need to know the actual physical dimensions of that screen to be able to calculate pixel per inch. Now, this is most applicable when there's going to be a really high resolution screen or a high resolution artwork, and you're worried about that transformation. So really, the screens should be listing their pixels per inch, and sometimes LED boards or other things that are more close or further away from the consumer TVs and consumer monitors will list the pixels per inch of their displays, and obviously higher numbers are going to be better there. Now, you can also use that information to figure out how big your artwork needs to be. For example, if you know that the pixels per inch of a given LED display is 150, and you know the dimensions of that LED display, you can work backwards to figure out exactly what dimensions you need to have that image rendered at to be able to fit it maximally. So that's pixels per inch, which I would summarize as saying the measure that relates the number of pixels in a digital image file or a digital screen display to the density of information in the real physical three-dimensional world. Similarly, DPI stands for dots per inch, and a dot is different from a pixel in that a pixel is set into an array of other pixels and viewed as a screen, whereas dots are used by printers to actually put down pigment on a paper and convert a digital file to a physical print on a piece of paper. So it's a little bit different, and there's not necessarily a one-to-one relationship between pixels and dots, although it's helpful to use that as a metric for sizing. So the printer's specs are going to determine how many dots per inch the printer can actually put down. I'd say the baseline or minimum for professional grade printing is 300 dots per inch, and fine art printing, especially like fine art photography, can actually go up to like 1200 or even 2000 or more dots per inch, but that's getting to be pretty large and expensive printers. So now that we know that the dots stand for literal dots of pigment that the printer puts down on the piece of paper, we can then use that information to figure out, based on an image resolution, or rather based on the desired dimensions for a physical print, what a good image resolution should be to ensure that there's enough pixels and information in that photo, and that the photo is big enough, if you will, for it to translate well and very sharply to a printed image. So for example, let's say we wanted to have a printed image that was 20 inches by 36 inches. And we wanted to print that at 300 dots per inch, which again is generally viewed as the industry standard for a baseline minimum. You do 300 dots times 20 inches, and know that we need a 6,000 pixel image resolution to be able to have kind of the best quality for our print. If you have an image file already, you can use this to figure out what the maximum print size it could be. So for example, working backwards, if I have a 2160 width image, and I want to divide that by 300, I can see that the maximum width using at least this DPI would be 7.2 inches. But if I wanted to print at, let's say, 72 DPI, that could get a print of up to 30 inches. So obviously, the less DPI, the less quality in the print. So I try and use this method and stick somewhere between 150 and 300. Higher is obviously better. Now, there are some times I've worked on freelance projects with graphic designers and creative directors who really should have a better grasp of this, but often there is a little bit of a miscommunication, and you might get requests for things like, give me this image in 150 DPI, or what size do you want the image at? Tell me the DPI you need. If they are, let's say, providing you with a digital file to use in a piece of work. Now, it can be stressful sometimes to push back, but it's necessary because the question doesn't make sense, and you can't possibly provide a strong response to that question because it doesn't have all the information required. Give me an image at 300 DPI is a perfectly reasonable request if it comes with a physical dimension for that image. If you know the image is going to be 20 by 36 inches and it's requested at 300 DPI, then you can do our calculation and understand that you need an image of at least 6,000 pixels in width to be able to satisfy the requested specifications. Similarly for PPI, but I find that is less of a confusion among people in the industry. DPI is definitely something to keep an eye out for. You may also see it come up if there are existing physical paintings or prints or something that needs to be scanned, and the scanning process may request a DPI, which is actually then going to be the inverse of what we just talked about, and that'll be the resolution of the scan. So higher DPI means more scans per physical inch in that context, which will result in a higher resolution digital scan image of the physical. So it's not very difficult, but it is helpful to have a good understanding of how all of these different measurements work and relate to each other so that you can, one, identify if an ask doesn't really make sense or if you need more information for that ask, and two, so that you can appropriately size all of your prints from generative artworks and beyond to be able to print them out in the highest quality possible. A final note, for those creating generative work, especially when changing dimensions is easy, it might be preferable to go through and kind of do this calculation first and then render your image in the full kind of native resolution. But in other cases, you may have a generative artwork that is already existing and maybe it's cumbersome to run the file again, or you lost it or whatever. And in those cases, I would recommend going through the same sizing process and then just intelligently cropping or upscaling using an AI upscaler, which I'm not going to go through in this video, but there's plenty free open source and paid commercial AI upscalers that you can use if you want to upscale and then crop, or just cropping based on how big your base image is. So now I think it's time to probably jump into TouchDesigner and just talk about how we can kind of do this in practice now that we understand what all of our terms actually mean. So here I have a very simple DPI scaling tox. And again, this is just using this artwork swept that I have created, and I'm just using this as a nice placeholder because I don't really need to then have a whole generative system. And so I will create a new base and jump in here. So we'll need some parameters on our base. First, we will use print dimensions, and this will be in XY. And then I'll default that to maybe 18 by 24. I will make a quick menu that's going to be print units. And these print units will have either inches or centimeters. And so that way we can support all of our friends all across the world, no matter where they are residing. And then we can use, finally, output resolution for print, which can be in XYs again. So I will take a parameter chop here. I will grab my print dimensions using the asterisk for X and Y. Now I'm going to have a math and a switch. And then I'm going to wire this parameter unaltered into the switch as well. This is the function store toolbar. If you're interested in that, you can grab it on his GitHub for free. It's open source. So if this print unit is in inches, then I'm going to have this be, okay, so actually I just switch these. And so if the print unit is in inches, I want to take this unaltered. If the print unit is in centimeters, then what I want to do is convert using this math chop to centimeters. And so that's going to be 1 divided by 2.54, which is how many centimeters there are in an inch. And so this will be centimeters to inches, and then this will be physical dimensions inches. Turn this back to inches. Very good. Now we'll give myself another parameter, and we'll call this print DPI. This can be a integer, and we can let that go, let's say a default of 300, and we'll go from 150 to 500 here on the range. Now we'll use another math here. We'll just multiply by this DPI. Call it times DPI. And then we'll use a rename to rename those parameters to output res X and Y using this pattern matching here. And so now we have output resolution X and output resolution Y. Now I will reference these values and turn this into a read-only parameter, just like that. And then it is as simple as using a fit top, fitting to this set reference, and then we're going to fit to this, and the fit type is up to you, but generally well, you can choose based on your use case. Fit outside is a nice default, and then if you want, you can translate to kind of choose which part of the image is being preferred. But I'm probably just going to leave this here for now. And again, this is only if you're going to be cropping or resizing an existing image. You could also fill if you prefer. I don't always love the distortion there, so sometimes I'll do outside and keep the proportions and just kind of chop off the top and bottom. And so now this is, let's put in a null and label resized for physical print. And there we go. And now as we change our DPI, we can see that our necessary resolution is going up and down. And the same, for example, if we want to use a centimeter measurement. All right, so we have some decimals that maybe we don't necessarily need to have in there, so we can use a limit, chop, and just turn on quantize, all sealing it, and just go to the actually, let's say maybe 10 to keep it nice and round. And so now we have nice round numbers, and we can call this DPI scaling for print. And there you have it. I'll leave this other component in there. It's slightly more fully featured, but I don't think it's worth spending the time to go through rebuilding all of those features. So I'll just leave that for my Patreons in the project file. As you can see, I have a toggle on and off for enabling or disabling print sizing. I also have the option to have a signature and add a little signature that you can move around using these sliders. And just some other information, print aspect ratio and output aspect ratio that I find helpful. The idea here is you can kind of just throw this at the end of your network and everything and always have a nice little signature. And if you just turn this off, it'll be whatever your project resolution is. And then you can just turn it on when it's time to print. And there you go. So I'll leave that for my Patreons. And for everybody else, can just follow along and rebuild this component. I will say before I go, thank you all very much for all the continued support. It's been truly life-changing and continues to be that way. So thank you all very much. Thank you for sticking around. And until next time, goodbye.